So, welcome to my YouTube channel on biostatistics and research. So, today we want to look at how to perform normality tests in SPSS. So, usually when you have data and you want to analyze for publication or thesis or dissertation, in statistics it is required that you perform a normality test to determine whether the data are normally distributed or not. So what in statistical terms we call parametric or non-parametric. So that will inform you as to which statistical tools you use for the analysis. So there are separate tools for parametric data and then another set for non-parametric. So using parametric approach for non-parametric might not be appropriate, and then vice versa. So how do you determine whether data is normally distributed or not? So we want to demonstrate that in SPSS. So let's say we want to determine whether this three, so age, height, ulna, and tibia, these four variables, whether the data is normally distributed or not. So how do you do it? So you go to analyze, you go to descriptive statistics, and then here you select explore. So when you select explore, you put your variables under dependent list. So we select these four variables, we put them under dependent list. Then you go to the statistics option. So you if you want to see also detect outliers, whether there are outliers in the variable, you select outliers, then continue. Then the plot, you want to see the normality plot for the test, so we select normality plot for with test, and we continue. So if there are any options here, there's nothing to change. So you click OK. So our results will be displayed very soon. So yeah, so this is the results for the analysis we have selected. So from the left pan, you can navigate. This is the navigation pan to see whatever is displayed. So you see our summary. So this is the title. We have the notes here. So we have the case processing summary. So this is just a summary. So the total data points is 135 for all of them. There are no missing values. So everything is 100%. So you have some descriptives here. So for each variable, age, you have the mean, 95% CI, the minimum, maximum. So these are just descriptive statistics for the various variables. So here is also a display of extreme values, if there are any extreme values. But here is not so informative, so we'll proceed. So this is what we are testing for. Test of normality. So this is where you find the results. And here there are two types of tests of normality. So you can see the Kolmogorov-Smirnov or the KS test. We also have the Shaprov-Wilk. So one may ask, which one do you use when you are doing normality test? So from literature, it's advisable to use the KS when you have a data size uh, greater or equal to 50. So from 50 data points and above, you use the KS. But when you have a smaller data size, less than 50, it is advisable to use the Shaprov-Wilk. So you can see that our data size or sample size is 135. So it's greater than 50. So we'll go with the Kolmogorov-Smirnov test. So you can see the p-values here. So for this test, the interpretation is said that when the p-value is less than 0.05, it means the data is not normally distributed. It's non-parametric. But when the p-value is above 0.05, then it means that the data is normally distributed. So if you look, you can see age and ulnar length are not normally distributed. They are non-parametric because the p-values are less than 0.05, while height and tibia are normally distributed because you have a higher p-value more than 0.05. So that is how. So you have to treat, in normal sense, you have to treat age and then ulnar. You have to analyze the data using non-parametric tests. Then tibia and the age and height, you can use parametric approach. So sometimes in order to treat non-parametric data as parametric, there are various forms of transformation. So you can do log transformation, you can do for radians, and then there are other forms of. So when you go to transform, you can transform a non-parametric data to parametric. But then in analyzing, you have to keep that in mind that the data has been transformed. So sometimes too, you might also look within the data, non-parametric data, to see whether there are extreme outliers, such that if they are removed, the data can become normally distributed. So one approach is to look at the stem and leaf, so you can see the distribution of the data, and then you can tell whether there are some extreme values. So we also have the KQ plot. So to determine whether the data is normally distributed, this plot try to fit the data points on the diagonal line. So for normal distributed data, there should be a linear relationship. So you also have the trended normal KQ plot. But here, the box and whisker plot is normally good when you want to see whether there are extreme outliers. So for age, you see that here there are no extreme outliers here. So let's look at height. So you can see data point 81 and 97 are potential outliers. These are potential outliers. So if you also look at for ulnar length, see the 81 is also a possible potential outlier. Then for tibia, so let's look for box plot for tibia. You can see there are extremely low values here, 82, 73, 94. And then high values also here, 97 and 81. So if you can decide to delete the records of that particular participant or data so that you remove the extreme values, or if the extreme values are less than, not too many, less than 5%, they can be deleted. Those values can be deleted and replaced with in the with a mean of that data set. So in a process called missing values, that's how you treat missing values. It can be replaced with a series mean, or other approaches can be used to replace this. So but usually this is the normality data. So age is not normal, it's non-parametric. Ulnar is also non-parametric, while height and tibia are parametric. So in SPSS, this is how you test for normality. Alright, so thank you for watching and look forward to my next video. Please subscribe and also share this channel to all those interested in statistics and then research. Thank you.